Hello everyone. So this is new chapter of greenhouse by Professor A.R.Shinde. Okay. So introduction. Depending on the local climate and the bioclimatic requirements of the species to be cultivated, once the proper site has been selected, it will be necessary to choose the cladding material, the type of structure, and the architectonic shape of the greenhouse. If the predictable climate generated by the greenhouse is not appropriate, complementary facilities and equipment for climate control will have to be considered. So here they are stating that uh, according to the environmental or outside climate, they have to we have to change the shape of the uh, roof truss or of the roof covering shape of the greenhouse. Okay, the architectural shape or the architectonic shape of the greenhouse for for as per the outside climate or conditions of the environment. Okay, criteria for the design of plastic film greenhouses. So criteria for this greenhouse design is very much influenced in practice by the local climate and the latitude of the site, and in many cases is limited by the availability of materials for the construction. No design is perfect, thus it is necessary to prioritize in each case the criteria to follow. This being the maximization of the light, minimizing if possible the structural elements to avoid shadows, ensuring good insulation which decrease the heat losses, affordable costs. So here they have told that the local climate is very much effective, or it has an adverse effect in managing the conditions or the convenient facilities in the greenhouse. Okay, so there are many things that can be prioritized with the orientation and all the facilities or all the natural conditions or dealing with the environment things. Okay, so here thus no design is perfect, thus it is necessary to prioritize in each case the criteria to follow. Okay, so what they have told us to have the necessary facilities from the environment point of view, or from the outdoor point of view, is that the maximization of the sunlight or the maximum sunlight should be reached or should be attracted towards the greenhouse. Okay, then minimizing if possible the structural elements to avoid shadows. So outside structural elements should be kept minimum as possible to avoid the shadows, so as to avoid the obstruction in the photosynthesis or process of the plants, which will be from the solar radiation. Okay, then ensuring good insulation which decrease the heat losses. Ensuring good insulation. Okay, so the heat losses should be uh, prevented by giving a good insulation in the greenhouse. Okay, and affordable cost, so it should be economical. Okay, the physical and mechanical properties of the covering materials and their availability limit the options while building a greenhouse. So there is certain trend among growers to build traditional greenhouses. So here there is availability, there is had some of them or growers or managers just they build a traditional greenhouse structure. Okay, they are not going for the advanced type of structure, that may be cost more costly, or that may be having high maintenance. So for reducing the mechanical and physical properties, they are just choosing the traditional greenhouses. Okay, relative to plastic film greenhouses, the most important aspect to achieve is as below. Besides the proper structural resistance to the wind, but also to the other predictable loads, snow crops which are trained to hang auxiliary equipment, the greenhouse must be built in a such way that the plastic film will remain well fastened, airtight, and without wrinkles to avoid breaks caused by the wind. It must be as well be easy to change the film. For this, the fastening system must be simple and efficient. The increasing cost of mounting the film and plastic materials have favored the use of special films with several years durability. For longer durability, if possible, the structural elements susceptible to heating up by solar radiation which are in contact with the plastic film must be insulated because excess temperatures contribute to shortening the shelf of the plastic film. Okay, so here they have shown that the structural resistance of the structure should be greater to the wind for the plastic film. Okay, plastic film should be made more tight, well fastened, and should be kept without wrinkles so as to avoid wind breaks or air breaks during wind flow. Okay, also to it should be kept in such a way that it should be easy for the maintenance and changing the films. Okay, also the increasing cost of these materials can be give rise to the yeah give rise to the using use of special films with more durability. Okay, for the longer use of plastic films or these roof covers, structural these films should be isolated or this should be insulated by the for the solar radiation, as solar radiation or high temperatures cause the plastic film to get the shorter life or get to damage. Okay, so next, when arcs or metal frames are used, the separation between them will depend on the predictable loads. Wind, snow normally does not exceed 3 meter. The greenhouse must be airtight to prevent night cooling in those climates in which low night temperatures are expected, as well as to prevent undesirable leakage of CO, that is carbon dioxide. A proper ventilation system is needed with airtight vents. The entrance of water from rainfall must be avoided. Its volume must be large enough not only to obtain a higher thermal inertia but also to allow for crops that are trained to grow up high supports and proper movement of the inside air necessary for natural ventilation. The unitary volume of the greenhouse is quotient between the greenhouse inner volume and the area that it covers being equivalent to the average height. Okay. So here the R's or the roof slopes are depends on the predictable loads that are to be undergoing the to it. Okay, then those may be wind, snow, or any type of lateral load. Okay, also the greenhouse must be kept airtight and also insulated so as to avoid any of the losses or heat losses, or also to prevent any insulation, and also it must be prevented that also this CO leakage should also be prevented so as to prevent the low night temperatures at the meantime. Okay, also proper ventilation system is needed in the greenhouse. So the passage or the span of the greenhouse must be kept much large enough so as to keep the warm air flowing in it, and for the proper growth of the plants it is necessary, as the growth of the plants of some plants is where has the growth of some plants is higher, so it is needed that the span or the height must be more. Okay, also the entrance of rainfall or water from rainfall must be avoided. It should be kept watertight. Okay, then collection of rainfall water by means of gutter for its lighter storage and use for irrigation is not only of interest in areas of low rainfall but also because the excellent quality of rainwater makes it especially valuable for soil-less cultivation, a technique for fast growth. The gutter must be 4 centimeters larger than the diameter of the drain pipe and must have a slope of 1% to avoid overflows. The minimum slope must be higher than 0.2% in any case. The drain pipes must have a cross section of 7 centimeters square for each 10 meters square of cover area that is to be drained, which caters for rainfall intensities of up to 75 mm per hectare. To avoid water dripping over the crops from condensation on the inner surface of the cover, it is important to build the greenhouse with roof angles greater than 26 degree. Such angles and also allow snow to run off the cover and have an appropriate collection system or to use anti-dripping plastic film. In unheated greenhouses where climate control is quite limited, the slope of the roof becomes relevant to avoiding condensed water dripping from the roof cover. Roofs with ogive shape might be of interest. Likewise, as general rule, the greenhouse must maximize solar radiation transmission at least in winter when it is lower, for which proper roof geometry and orientation the are the fundament. So here they have also stated that the rainfall water collection should be done through the gutters or the drainage area or the passages should be kept for collecting the rainfall area. It is of great use in the areas where lower rainfall is recorded. Okay, so it will be be a fine source of water for where the water shortage is there. Okay, also the water dripping from the inner surface of mm, uh, inner surface of roof covering is observed in from the over the crops from condensation. So the greenhouses should be built with roof angles greater than 26 degrees so as to allow the runoff, so as to allow snow to run off the cover. Okay, and also the anti dripping plastic film is also used for this purpose. Okay, and also they have also told the some type of slope of the roofs are to be done to avoid this condensed water dripping from the roof cover. Okay, and the greenhouse solar radiation must be must maximize transmission the roof geometry or many dimension orientation or the location orientation or any type of difference in the orientation can make the changes in a greenhouse. So the changes should be made to in winter for getting the maximum sun solar radiation. Okay, by changing the or by seeing the orientation. Okay, these are the different uh, type of curved roof greenhouses. Okay, first is semicircular. Okay, this is semicircular greenhouses, this is semi-elliptical, this is gothic or ogive type of greenhouse. Then this is asymmetric, this is attached lean to single span, and this is single tunnel. Okay, so this design criteria in areas with a Mediterranean climate. So the most limiting climate conditions for greenhouse cultivation in Mediterranean climates are low night temperatures in winter, high daytime temperatures, high ambient humidity at night, and low values during the day, and CO depletion during the day. Therefore, it is especially necessary to achieve efficient ventilation, which allows for alleviation of the thermal excess and extreme humidity and prevents CO deficiency. Depending on the type of greenhouse and climatic condition, it is advisable that the ventilation area is up to 30% of the ground area of the greenhouse. The increasing use of insect-proof screens in the vent to avoid or limit the entrance of insects decreases the efficiency of ventilation. Collection of rainfall water must also be a priority. In the low cost type greenhouses, the general problem of condensed water dripping is aggravated in flat roof greenhouses, inducing serious plant protection problems as it facilitates the development of diseases. Thermal losses must be limited by choosing a suitable cladding material and making it as airtight as possible. Night heating may be necessary for the crop during the critical winter months, but its economic profitability is questionable in many cases. Okay, so here they have uh, stated that the limiting conditions in the Mediterranean climates that are low temperatures in winter, high day temperatures, high humidity at night, and low values during the day. Also, carbon dioxide depletion during the day. Okay, so these are the climatic conditions in the Mediterranean area, okay, regions. Therefore, the ventilation is it is necessary to achieve the ventilation in this type of climate so as to gain the thermal excesses and you prevent the humidity and also to prevent the CO depletion or CO deficiency. Okay, the climatic condition of this region uh, favors the attacks of the insects and decreases the ventilation. Okay, so insect proof screens should be used for uh, as an obstruction to these insects. Okay, and the low sorry the rainfall water should also be connected in these regions so as to avoid the scarcity of water. Okay, also the thermal losses must be limited by choosing suitable cladding material. Okay, so the heat losses should be avoided using suitable material, and also night heating should be done for the craft as there are very critical winter months, but it may be uh, be not economical, so it must be looked for. Okay, then we'll go further. Design criteria in humid tropic climates. The high rainfall during the whole year or during the rainfall season, which includes high RAS, the stability of the temperatures high during both the day and the night throughout the year, and the solar radiation, which may be excessive in some cases, are the most outstanding characteristics of humid tropical climates. As a consequence, in these greenhouses, protection against the rainfall must prevail, the greenhouse umbrella effect, and there should be efficient permanent ventilation with vents frequently equipped with screens to prevent the entrance of insects, as well as a good height and sufficient resistance to withstand strong hurricane winds, which are usual in such climates. Figure 5.4.1 shows some of the solutions for humid tropical climates. Achieving a compromise between these requirements at low cost is not easy. So for the humid tropical climates, they have said that the the whole that climate is of the rainfall whole year there is a rainfall due to the humid climate, and for the solar radiation or the solar access is hard to find for the plants or for the greenhouse. Okay, and also the greenhouse protection must be there from the rain, as it should be a very properly airtight, and the proper ventilation should also be given for the greenhouse, as there are heavy rainfall and this type of problems. Okay, also good height and sufficient resistance to withstand hurricane winds uh, should be provided. Okay, as there are this area has a great rainfall, there are many types of insecticides insects are seen in these regions, so this should be avoided using suitable types of screens as a obstruction. Okay, and all these problems are not easy to achieve at the lower cost, so this should be properly checked and looked. Okay, then these are the greenhouse structures used in tropical regions. So as there are high or heavy rainfall in these areas, so these are the various types of collector drainage systems are used in on the top of the roofs. Okay, we can see here also the sloping or slope is seen on the roof coverings. Okay, greenhouses for other climatic conditions. In dry desert climates, the extreme temperatures values are more acute than those experienced in Mediterranean climates, and the ambient humidity is notably lower. The winds being frequently loaded with sand and with every low water content. In these conditions, high ventilation capacity and efficiency is a priority, with the possibility of tightly closing the vents, and there is possibly a need of humidification systems if the evapotranspiration of water is insufficient to decrease the temperature and increase the REH, preventing thermal losses at night. is necessary. So choice of proper cladding material and is enough. Ceiling and enough ceiling are important. Sorry, cladding material and enough ceiling are important to avoid the need for night heating. The structural resistance to the wind is fundamental, and the collection of rainfall water for irrigation is normally desirable. Under cold climate conditions, the greenhouse effect must be enhanced, and normally the maximum solar energy collection should be reached with proper roof geometry and cladding material as well as optimized greenhouse orientation. Limiting thermal losses is always desirable using proper cladding material, thermal screens, and being as airtight as possible. Frequently, the insulation measures to reduce thermal losses imply a decrease in available solar radiation. The double wall decreases the transmission. The thermal screens generate shadows even when folded. So it is not easy to obtain a compromise solution which must be based on profitability criteria in each specific case. In these cold climates, the obvious choice between multi-span and single-span greenhouses is clearly for the first type. Heating is a must not just during the winter months, and ventilation is necessary during the season of high radiation. In some cases, greenhouse cladding with screen aims at achieving a windbreak effect, a shading effect, or plant protection, limiting the access of pests when the natural thermal conditions are adequate for crop growth, and therefore a greenhouse effect is not pursued. So there they have given us the greenhouse structure for the and the conditions and other climatic regions. Okay, so in dry regions there are dust winds or dust hurricanes are seen. So also there is a notably lower humidity is seen. So we should and high radiation solar radiation is seen. So there should be a proper ventilation. High ventilation should be provided in those greenhouse where in dry desert climates. Okay, as they due to solar high solar radiation, ventilation is highly difficult. So proper ventilation systems should be provided, and the decrease temperature decrease temperature low managing the temperature at daytime should be done. So the thermal losses is and also thermal losses or the heat losses in the night is also necessary, as the absorbed radiations are uh, exhausted at night. Okay, and in the cold climatic conditions, the solar energy should be achieved at maximum efficiency by taking proper orientation or proper geometry or using proper cladding material or glazing materials. Okay, so this was all about this greenhouses for climatic conditions. Okay, so we'll see another topic at another lecture. Thank you.